Construction is changing faster than ever, and new technologies are pushing the limits of what we can build. Today, we're exploring the next-level innovations reshaping job sites around the world. If you've ever wondered how engineers manage to run huge pipelines or fiber optic cables under rivers, highways, or busy city streets without digging everything up, the answer is horizontal directional drilling, and it's far more advanced than it looks. HDD works like an underground navigation system, allowing crews to drill a precise tunnel beneath the surface while leaving the ground above almost untouched. It starts with a steerable pilot drill that threads its way through soil using real-time guidance, curving around obstacles and holding an exact path. Once the drill reaches the exit point, the borehole is carefully enlarged, and the final pipeline, whether HDPE, steel, or PVC, is pulled smoothly back through the tunnel. This trenchless method avoids traffic disruptions, prevents environmental damage, and eliminates the need for deep excavation, making it ideal for crossing rivers, railways, wetlands, and urban areas. The process is faster, safer, and far less intrusive than traditional digging, while also protecting existing utilities and reducing restoration costs. From oil and gas lines to water systems and high-speed internet cables, horizontal directional drilling is the unseen technology quietly reshaping underground infrastructure with precision and efficiency. When it comes to protecting cities from flooding during heavy storms, the Contech Stormwater Detention system delivers one of the most effective and scalable underground solutions available. Instead of allowing excess rainwater to overwhelm drainage networks, this system temporarily stores runoff inside large modular chambers built from corrugated metal pipes, concrete vaults, or reinforced plastic units, many of which range from 1 to 12 feet in diameter. Depending on the design, these underground systems can hold anywhere from thousands of gallons to several million gallons of water, making them suitable for everything from small commercial sites to massive municipal projects. The structures are buried beneath parking lots, roadways, and open spaces, creating hidden reservoirs without consuming valuable land. Inside, engineered flow control devices carefully regulate how quickly water is released back into storm drains or natural waterways, preventing dangerous peak flows that trigger flooding. The system can also integrate pre-treatment filters to trap sediments, oils, and pollutants, improving water quality before discharge. Built for high load-bearing strength, corrosion resistance, and long service life, Contech detention systems help keep streets safer, protect infrastructure, and support sustainable urban development by managing stormwater where it matters most. Moving on. Now here's how to save yourself a major headache when building a house. Simply let the robots do everything. The Apis Core 3D printer is one of the most advanced construction machines in the world, designed to print entire buildings directly on site with remarkable speed and precision. Using a 360-degree rotating robotic arm, it extrudes a specially engineered, fast-setting concrete mix layer by layer, forming strong monolithic walls without the need for traditional brickwork or heavy manual labor. Unlike fixed-frame printers, Apis Core is fully mobile and compact, allowing it to be transported to remote or tight locations and set up in minutes. It can print structures up to 3.1 meters tall and reach a radius of up to 8.5 meters without repositioning, dramatically reducing construction time. The printed walls offer excellent durability, energy efficiency, and long-term stability, while the process itself cuts material waste and labor costs significantly. From affordable housing and disaster relief shelters to commercial units and innovative architectural designs, Apis Core is showing the world how robotics and 3D printing can reshape the future of construction, one layer at a time. If you've ever seen workers struggle to break old concrete with jackhammers or heavy machinery, you'll understand why hydro-demolition robots are becoming the smarter, safer, and more precise solution. A hydro-demolition robot uses ultra-high-pressure water jets, often between 1,000 and 2,500 bar, to remove damaged or deteriorated concrete without harming the steel reinforcement inside. Instead of vibrating or cracking the structure like traditional methods, the robot selectively blasts away only the weakened concrete, preserving the integrity of the surrounding material. These robots are remote-controlled for operator safety and are equipped with articulated arms and automated nozzles that maintain consistent pressure and depth, ensuring uniform results across bridges, tunnels, dams, parking structures, and industrial facilities. They significantly reduce dust, noise, and micro-cracking, making them ideal for sensitive or occupied environments. Hydro-demolition also creates a rough, clean surface that improves bonding for new concrete overlays or repair materials. Because there's no impact force, the remaining structure stays stronger and lasts longer, while the process itself is faster, more efficient, and environmentally friendly, capturing water and debris through integrated suction systems. Overall, hydro-demolition robots represent the next level of precision concrete removal, combining speed, safety, and structural protection in one advanced machine. When you need concrete floors that are laser flat, extremely durable, and finished in a fraction of the usual time, the CopperHead Laser Screed XD 3.0 delivers professional-grade results on every pour. This advanced walk-behind laser screed uses a precisely controlled vibration system and an integrated laser leveling sensor to strike off concrete with incredible accuracy, helping contractors achieve industry-leading floor flatness and floor levelness numbers. Its telescoping screed head and lightweight frame allow crews to operate efficiently in tight or crowded areas where larger boom screeds cannot reach. Powered by a reliable gasoline engine, the XD 3.0 features automatic height adjustments, consistent vibration output, and smart steering controls that drastically reduce operator fatigue while maintaining a flawless finish. The machine typically covers 16 to 20 feet of screeding width, depending on configuration, making it well-suited for warehouses, slabs on grade, parking structures, and commercial flooring projects. Built with heavy-duty components and engineered for long-term job site performance, the CopperHead XD 3.0 minimizes manual labor, improves productivity, and ensures a smoother, stronger slab every time. In India, builders are using Coir Geotextiles to create stronger, more sustainable infrastructure in regions where soil erosion and weak subgrades are constant challenges. Made from the natural fibers of coconut husks, these geotextiles are woven into mats, nets, and meshes that stabilize soil, reinforce road bases, and protect embankments from rainfall runoff. Their open-weave structure allows water to drain freely while locking soil particles in place, preventing washouts even during monsoon seasons. Coir has impressive tensile strength and can last 3 to 5 years in the ground, long enough for vegetation to establish and roots to permanently secure the slope or roadway. Over time, the material biodegrades into organic matter, enriching the soil instead of leaving behind plastic waste. India uses Coir Geotextiles extensively in highway projects, rural road networks, hill area stabilization, riverbank protection, and landslide-prone zones, especially across Kerala, Tamil Nadu, and the northeastern states. By combining traditional natural materials with modern geotechnical engineering, Coir Geotextiles are helping the country build resilient, eco-friendly roads and landscapes that stand up to harsh weather, while supporting long-term soil health. Facade construction is one of the most important parts of the building industry, and a team from Belgium has introduced a system that completely changes how brick walls are built. Instead of using mortar, cement, or traditional binding materials, the Facade click system works as an all-in-one mechanical solution. Special connecting elements allow bricks to lock together row by row, making it possible to build complete brick walls without mixing or waiting for mortar to dry. The bricks are made with small holes that fit these inserts perfectly, creating a clean and even look with narrow gaps between each one, about 1/8 of an inch. Each layer simply clicks into place, ensuring precision and consistent alignment throughout the wall. The result is a high-quality bricklaying system that works in almost any weather condition and can be installed up to 7 times faster than traditional methods. The final row is secured using special screws to ensure long-term stability. If changes are needed later, the wall can be easily taken apart and rebuilt without damaging the bricks. This approach reduces labor costs, improves construction quality, and minimizes material waste. According to reports, walls built with Facade click can achieve significantly higher structural strength than conventional brickwork, making this patented system a major advancement in modern facade construction. The Gtek SBM 8 system is engineered specifically for producing high-quality, lightweight foam concrete, a material widely used for walls, partitions, floor fillings, monolithic frames, and even foundation applications. This machine integrates a built-in foam generator that creates fine, consistent foam and mixes it thoroughly with the binding agent or glue, ensuring a uniform cellular structure with excellent stability. The system can also be equipped with an onboard compressor and a water pressure enhancer, allowing it to operate as a fully self-contained foam concrete production unit. One of its major advantages is efficiency. When using a protein-based foaming agent, builders can achieve savings of up to 30% per square meter, thanks to reduced material consumption and improved yield. The foam produced is resilient and maintains its structure during mixing and pouring, which results in concrete that is strong, lightweight, and free from common problems like efflorescence. By combining precise foam generation with controlled mixing, the Gtek SBM 8 delivers consistent performance for a wide range of construction tasks, making it a valuable solution for modern, cost-effective building projects. Now let's look at a slab formwork system that makes building concrete floors much faster and easier. Instead of using heavy timber panels or complicated setups, this system relies on large aluminum panels that rest on simple props and connect through a smart drop-head mechanism. The panels come in sizes like 2400 by 1200 millimeters or 1800 by 1200 millimeters, with a lightweight design of about 17 kilogram per square meter, creating a clean and even surface for pouring concrete. It can support slab thicknesses up to 350 millimeters with the larger panels and up to 550 millimeters with the smaller ones, giving builders plenty of flexibility. Because the drop head allows panels to be released early, crews can reuse them right away, which greatly speeds up each construction cycle. The system also uses fewer parts and requires less training, so workers can assemble it quickly, even on busy job sites. Since the panels are made of aluminum, they resist moisture, do not warp, and last much longer than timber. This approach is already used in many residential, commercial, and high-rise buildings where fast slab construction is important. One major benefit is that it reduces material waste and labor costs, helping contractors stay on time and on budget. It also cuts down the need for cranes and heavy equipment, making the entire process safer and more economical. Imagine stabilizing a failing slope or supporting a heavy building from below without using large drilling rigs or causing major ground vibration. That's exactly what the Titan Micropile system is designed to do. This smart foundation technology uses a hollow steel bar that works as a drill rod, a grout injection tube, and the permanent reinforcement, all in one continuous process. Once the hole is drilled, a cement suspension is injected to clean and stabilize it, and then a stronger grout forms a solid grout body that transfers loads safely into the surrounding soil. Built to last more than 100 years under strict German approvals, these micropiles are ideal for foundations, underpinnings, tunnels, slopes, and even mast or pylon supports. Because the drilling equipment is compact and vibration is minimal, the system can be installed in tight spaces or sensitive areas with very little disturbance. The fine-grained steel tendon and controlled grout design keep crack widths below 0.1 mm, preventing corrosion without needing extra protection. Depending on the bar size, each micropile can handle loads from 190 kilonewton to over 3,100 kilonewton, giving engineers tremendous flexibility for both tension and compression demands. Overall, Titan micropiles offer a strong, durable, and highly adaptable solution for modern construction, especially when time, space, and soil conditions make traditional foundations difficult. That's all for today, friends. Thanks for exploring these next-level construction technologies with us. Until next time, keep learning, stay inspired, and watch how innovation continues to reshape the world around us.